So here is how I got the answers for number 4. So you can check those out and see whether you got it right. And so now we are going to number 2. So I know you wonder if I know how to count, but I'm going back to number 2. Casey Clark led the women's pro softball league in strikeouts. Suppose she throws the ball at an angle of 5.2. Okay, so she's thrown that at 5.2 degrees at a speed of 67 miles per hour. Here's the problem. That's not feet per second. So we have to change that to feet per second, which makes us so excited because then we could do dimensional analysis. Right? So you need to know how many feet are in a mile. Hopefully you know that's 5,280. If you don't, you should learn it. Okay, remember that 5 tomatoes is what somebody does. I don't know if that'll help you. All right, I need it not to be in hours. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So when I multiply all this out, okay, I'm going to multiply all that out, and I'm going to find out that it's 98.3 feet per second. That's her velocity. So she's going 98.3. So write your parametric equations. X equals 98.3 cosine 5.2 times t. Y equals negative 16 t squared plus 98.3 sine 5.2 times t. Now here it says she releases the ball 2.7 feet above the ground. Okay, because she's throwing the ball. She's not throwing it off of the ground, so her initial height here is 2.7. So that's just going to add a little different element than so far we've had everything with a height of 0. So it says the distance from the pitcher's mound to home plate is 43 feet. This distance is 43 feet. So isn't that what this is? So couldn't you solve for that? If you let this be 43 equals 98.3 cosine 5.2t. So divide both sides by 98.3 cosine 5.2. 98.3 cosine 5.2. Make sure you put those in parentheses. And when you do, you're going to find out that the time is 0.44 seconds. That's how long it takes till this ball goes from here all the way 43 feet and crosses home plate. So the question, though, is how far above the ground is the ball when it crosses home plate? Okay, so actually I forgot to say that okay, so actually what I should have said, I should have looked at the question initially, which says how far above the ground is the ball when it crosses home plate. So how far above the ground makes you think that you need the y. But the problem is that you don't know the t, right? So you can't find the y if you don't know the t. So that's when you go to the other equation, and that's why I went to here and I solved for that t. Okay, that's how I knew to do that. But now that I have the t as 0.44, couldn't I put the 0.44 in right there for this and just y equals that? And then that is going to tell me that the ball, if you multiply that out, is 3.52 feet above the ground, which makes sense. If she's, throwing this ball off the pitcher's mound, hopefully when it crosses the pitcher's mound, or when it crosses home plate, it's 3.5 feet high, which would be maybe in the strike zone. Yay, Casey. All right, we are moving to number 5. I know this is really fast, and I am really hoping that you are remembered to pause this video all the time. So on number 5, it's a lot like number 2. Human cannonball is shot out of a cannon with an initial velocity of 70 miles in 1 hour. All right, 10 feet above the ground at an angle of 35. So there it is, it's going 35 degrees, and it's starting up here 10 feet above the ground at the initial height. So again, you have to do all this stuff, 5,280 feet in a mile. And then switching the hours here, minutes. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. If you multiply all that out, you get 102.7 feet per second. And you should really spend the time to actually do that on your calculator. So this is 102.7. So you can write your parametric equations. 102.7 cosine 35 times t. Negative 16 t squared plus 102.7 sine 35t. And the human cannonball started 10 feet off the ground. So there you go. Again, what is the maximum range of the cannon? That's this whole thing. Okay, it's going all the way to here, to where the guy goes splat on the ground. Okay, so we're shooting the cannonball from right up here, and he goes splat on the ground. That's not where he's going to end up being, but that would be the maximum range. So in order to figure that out, don't you know that the height would be 0 at that point? So 0 equals this. That'll tell you when, but it's not going to tell you this. What it'll do is it'll tell you the t, and then you can find out the maximum range. So you have this. Okay, you can't really solve this by hand. You have to put it into the calculator. Okay, so you're going to put it into the calculator. You're not going to be able to see it when you graph it. It's going to look sort of like this. Right? So you're going to have to change your window. I'm going to set my Ymax at 100. Okay, make sure you're in degrees again. And then when you do it, you're going to be able to see the top of this. Okay, and when you want to find out the t, remember these t's are acting like x's. You know, here's the y, these are acting like the x's. So that's going to tell you the x distance. If you're trying to figure out how far this is, okay, right now you want the t, you want to know that. So you're going to go second calc the 0, left bound and right bound. All right, and when you do that, you're going to get 3.84 seconds. Okay. Okay, 3.84 seconds is when the human cannonball is dead. Okay, he's hitting the ground. He is dead. That is not what we're hoping for, but anyway, it is going to tell us the maximum range of the cannon. I'm going to put this number in right here. So when I multiply by 3.84 right here, the maximum range of the cannon, multiplying all this out, gives you 323 feet. But again, at 323 feet, if you put his net right here, he's dead. Poor guy. Hope he has some good insurance. All right, so for part B, we have how far from the launch point should a safety net be placed if the human cannonball is to land on it at a point 8 feet above the ground. Okay, so there's a safety net right here, 8 feet above the ground. We are not waiting until he's dead on the ground. That is good news. Okay, this is somebody who takes their job seriously. So if that's going to be the case, don't you want the height to be 8? So all I'm going to do is right here, that's going to be 8. And then if I wanted to solve that, this has to be 0 in order to be able to graph it. So I'm going to subtract 8 from both sides. And so now I have 0 equals negative 16t squared plus this, and then plus 2. So now you put that into your calculator. Okay, you're going to end up getting a different, slightly different graph. And you want to find out now what this is. Okay, so you're going to hit second, calculate 0, right? And then left bound, right bound, and you're going to get 3.72 seconds. That's the time. That's actually the answer to part C. How long is the flight? And then to find out how far from the launch point, okay, I'm going to put this 3.72 seconds in right here. And I'm going to multiply this out. And so when I do, I get 313 feet. So at 323 feet, the guy's dead. At 313 feet, this would be 313 feet, then he's 8 foot up, and he's landing safely in the net. So glad. Okay, so homework tonight. It says that you have to finish a worksheet. We have finished this worksheet, so if you're listening to this for the first time, go to that other worksheet that we were working on last time in class. It's on the back of the day 4 warm-up, and I want you to do numbers 1, 4, and 6 on the top, 2, 4, 8, and 9 on the bottom. All right, have fun.